Welcome to my channel. In this video, I will teach you what is XRD. XRD stands for X-ray diffraction. It's a technique used in material science, chemistry, and physics to analyze the structure of crystalline materials. XRD works by the shining X-ray onto a crystalline sample and measuring the angle and intensity of the X-rays that are scattered by the atom within the crystal lattice. This information can then be used to determine the arrangement of atoms within the crystal and to identify the crystal structure of a material. Furthermore, X-ray the XRD used for to identify whether the sample have a crystalline structure or amorphous structure. It's also used to identify the existence of multiple phases. What is the composition, and also it's give information about the microstructure and nanostructure of the material, which is considered to be the qualitative information. This is the graph which you obtained as a result of XRD. So this is the XRD graph, and these peaks are as a result of diffraction from the Bragg's plane. So the maximum peak have a high intensity, and it represents the plane 111, and this is the second one, and it represents the plane 002, and this represents the plane 103, and this one 112. So it occurs as a result of when X-ray beam fall on a sample at a specific angle. It gives a specific diffraction, which is represented by this peak. So now we are going to explain the XRD based on Bragg's law. So XRD is based on a Bragg law, which describes the condition for constructive interference of X-rays scattered by the crystal lattice. The Bragg's law states that n lambda is equal to 2d sine of theta, where n is the integer representing the order of the diffraction peak, and lambda is the wavelength of the incident X-ray. D is the spacing between the crystal lattice plane, and theta is the angle of incident of the X-ray with respect to the crystal lattice plane. Further, moving it on, when X-ray are incident on a crystal sample, they interact with the atoms in the crystal lattice, scattered in various directions. However, if the condition described by the Briggs are met, the scattered X-ray will constructively interfere, resulting in diffraction P. XRD experiment typically involves varying either theta or wavelength lambda. If the incident X-ray, while measuring the intensity of the scattered X-ray by analyzing the position and intensity of the diffraction P, scientists can determine the spacing between the crystal lattice plane and for information about the crystal structure of a material. This is the process which we uh, discuss in theory. So this is the practical way how the Bragg's law equation derived, and how we get a plane, that's the peak we see. So these are the incident beam X-ray. There's the ray 1 and ray 2. When it fall on a sample, there is a surface of a sample, and described here as atomic plane. These are the plane on which rays are fall. So this is the ray 1, and this one is the ray 2. When it fall on a atomic plane, it will reflect or scatter with some angle. So you see that this angle is equal to this angle, and the same way the second ray transmit and reflect from a second plane. So the angle between the incident and the diffracted ray is theta. And now we are going to derive the equation 2d sine theta is equal to n lambda, which is the Bragg equation. So the plane CB and BD is equal to d sine theta, as mentioned in the figure, that d sine theta is equal to CB on one side, and the other hand BD is equal to d sine theta. So we get this equation, that is CB is equal to BD sine theta. Now the part difference between the ray 1 and ray 2 is equal to CB plus BD, and putting the value, that is d sine theta plus d sine theta is equal to 2d sine theta. Condition for the maximum path difference is n lambda, where n is the integer, the first, second, third order of maximum, that is respectively. So putting these value, path difference n lambda, and we get this equation. This is known as the Bragg's law of X-ray diffraction. Thanks for watching. If this video is informative for you, please like the video and subscribe to our channel. Thanks for watching.